Now you are also supposed to graph the relation in its inverse. So we'll go to a new slide here. And we'll pull up some graph paper, and I'll supply graph paper for you guys. So you have it, and go ahead and take the time to put it on graph paper. Okay, so we'll take the original function, and I have the luxury I can mark stuff in colors, so blue will be the original relation. And we just graph those ordered pairs. We've got -3 goes to 2, and -2 goes to 2, and -1 goes to 2, and 0 goes to 2. And then we'll change colors here. We'll make this kind of reddish color is the inverse. And the inverse, when x is 2, it goes to -3. When it's 2, it goes to -2. When it's 2, it goes to 0. And -1. So there is the original function in blue and the inverse in red. The next problem, see, we had to do 5. Let's go ahead and do 5 really quick. Take too long. So problem 5. Now this is a group, so what you may want to do is list the directions. At the very beginning, we've got to find the inverse, and determine if it's a function. So problem number 5, they give us y equals 3x plus 1. And we're going to go about finding the inverse. And if you recall from class, what we do is we do what inverses do, and they flip-flop the x and the y value. Oops, plus 1. And then we solve it for y. So we go x minus 1 equals 3y. And we divide by 3, so y equals x minus 1 over 3, which is fine. However, we're used to slope-intercept form, so we're going to write it as 1/3 x minus 1/3. There's a lot of ways to determine if this inverse is a function or not, but let's first of all get our notation correct. So the original function f of x is 3x plus 1, and the inverse function f inverse of x is 1/3 x minus 1/3. And this one, we can say yes, that's a function because it's not a vertical line, so it passes the function test. It goes at a slope of 1 over 3. Yes. And we want to make sure that we've shown our full answer there. Okay, so that should get you through that next group. 14, we have to graph the relation. Its inverse. 14 shouldn't be too bad. 17, let's go ahead and do 17 so you can see what that looks like. Okay, we're supposed to graph the relation. This is for a couple of the problems. Graph the relation and its inverse. Okay, so in 17, our relation is given to us as 3x squared. Now, you could find the inverse if you wanted to. We don't necessarily need to because it said to just graph them. Let's go ahead and do it. So we flip-flop x and y. We're going to solve this for y, so we divide by 3. And we square root both sides. So it's plus or minus. Remember, we get plus or minus when we square root. So there would be one form of our answer. This would also be another form of our answer. There rationalize the denominator. What they wanted us to do, though, is graph both of these things. I'm going to throw some graph paper in here. It should be good enough. And in green, let's go ahead and graph the original function. It's a parabola, or vertex is at the origin, right there. We can just create a chart of values. 0 gives us 0, 1 is 3, 2 gives us 12. I'm going to run out of room really quick. Symmetry tells me about the matching point, so we can see this parabola looks something like that. Okay. Now what I would always do when I'm graphing a relation in its inverse is I would draw in this line right here. This is the line y equals x. Notice it's at a 45-degree angle. It contains points like 1, 1, 2, 2, 3, 3. There's 2, 2, there's 3, 3, there's 4, 4. That's the line y equals x. And if you don't want to generate your own points, we can just steal points from the original function. Okay, so 0, 0 is going to be on it. And now we flip-flop the 3 and the 1. So x is 3 when y is 1. And x is 12, way out there. So we're not going to be able to get to that. But symmetry tells us we have another point down here. And so our inverse looks something like that. Okay, you guys don't have colored pencils, so you'd say this is f of x up here. It's the original function, and we really can't use functional notation for this one in red because we can see that flunks the vertical line test, so it is not a function. Number 20 is very similar. Let's jump to 23, and that will be our last one that I do. Problem 23. Again, let's get the directions down. For each function, since this is a separate section, I'd write it at the very beginning. For each function, find f inverse for each f. And the domain. Domain's one that we have a difficult time with, of f and f inverse. Determine if f inverse is a function. Okay, so here we go. Number 23. We've got f of x equals 3x plus 4. Okay, if we think about this one for a second, it is a line. I'm going to go ahead and sketch it really quick so you can see it. Make it not too big. This is a line with a y-intercept of 4 and a slope of up 3 over 1 or down 3 back 1. So it's this line right here. Let's see if I can draw a straight line with these tools that I have. There we go. And let's make it kind of thin. Looks about right. Let's put it in black. So it's this line right there. Now this line goes forever downward, forever upward. So our domain for this is all real numbers, and our range is all real numbers. It goes forever in the x directions, and it goes forever up and down. Next we find the inverse of it. So we're going to write it in y notation. We're going to flip-flop x and y, and we'll solve for y. When you solve for y, you get y equals x minus 4. We subtracted the 4 and divided by 3. So again, we'll put it in slope-intercept form, minus 4 thirds. We can tell since, let's go ahead and sketch in this inverse. Hopefully you could tell at this point that the inverse is a function. Okay, and because of symmetry, or the reflection about that line y equals x, it's pretty easy to draw this one. It looks something like that right there. Put some ends on it because it goes forever that way and forever that way. And so our domain is all real numbers. And actually, all we have to do is steal the range, because the range becomes the domain, and the domain of the original function becomes the range. Okay, so this is our inverse function. I'm going to have a little bit of room, and our is right here. We'd use our notation for that, and that was our original function there. And I think that should be enough to get you through all of the homework.